Well, today I put my new LMD Wave high energy antenna system up in the air on some coax, and I made a very interesting observation. Initially, I actually rose it up to this height, which is close to a half wave on 40 meters, okay? And I started a 10-watt beacon from the trailer, and I went over to my mobile, the vehicle, and I started a 10-watt beacon on its high energy vertical antenna so that I had a stable reference. And I started monitoring on an SDR in South Australia, and I checked a few others. And what I found interesting is that the signal from the mobile and this antenna when it was up here were around about comparable. So I thought that's interesting, because I did notice when this was in the house yesterday, I also went out with my mobile and was doing simultaneous observations on SDRs, and this antenna in the house was comparable to the mobile. They were varying, but it was very interesting. So I thought, now what's going on here? So while monitoring the two signals, I slowly descended this antenna until I got the optimum result on an SDR, and it happened to be at this height, which appears to be about a quarter wave. I've yet to pull it down, mark the bottom of the coax and then pull it down and measure that exactly so I can reverse engineer this math. But it appears to be a quarter wave. And then this rose about 3 S points. And I thought maybe that's because of, reflections. I'm on a slope block and it's a takeoff angle issue. So I then observed on an SDR in Croydon, which would normally require MVIS, and there was the same sort of increase there. I checked in Western Victoria and in the north, which is up the hill, into Kahuna, northwest from here, and amazingly enough, the same increase. So I then realised, so I've just got to stop this thing from making all this noise. It's when it, oh silly phone, when it closes down, it starts farting. So I then theorized that because although I'm running it with an unbalanced line, it does have a kickback onto the coax shield. And that kickback pulse, when it comes down, obviously wherever it hits ground, it then has to kick back up. So this becomes part of the phasing of the system. So if you imagine when the hot element on the top becomes peak positive, the top of the coax shield becomes peak negative. If it's a quarter wave above the ground, by the time that peak negative has made it down to the ground 1/4 and then back up to the top of the coax, which is 2/4, a half a wave cycle, the source point has made that now maximum positive because it was maximum negative. Now, this negative that came down and has gone back up, that's meeting the maximum positive, is not a cancellation, because when it started it was traveling down, but when it's coming back up it's traveling up, and therefore it's changed sign. So quite literally it's adding to the new positive. So it's quite literally a phasing resonance factor with the coax line. So a great observation there, and it becomes additive. So now this is in VK5. Actually, I'll go to shade, stand by. Okay, so this is it now into VK5. And it's been doing a beautiful job, much stronger. And the ionospheric conditions are not yet suited from my location to that location optimally yet. Had a look on the hourly HAP chart, and it's still around 10 or so megahertz, so a bit high. What I'm thinking is I'll mark that point where it touches ground on the coax, and I'll bring it down, and I may cut through the shield of the coax and add a high value choke, so that can be the point of rebound. But then again, the choke takes time to build up the magnetic field and kick back. I might even add a choke further up the coax and magnetically vary it so I can tune the reflection on the shield of the coax. So very, very exciting observation. But yeah, that's pretty impressive there for that tiny little thing, isn't it? So this is the updated hourly HAP chart. So based on my location in the green there to the destination, which is in that light blue, the optimum part of the spectrum for that trip right now, the light blue, is actually up at 12 megahertz. So normally I only get in there decent when it gets down, into the green or the brown, the 8 or 6. So when that shifts up, it'll be very interesting to see how this is getting in. Now for NVIS refraction though, it's optimal. I'll just pull that up. Let me see. Sorry about my bad camera work. SWS ionospheric map. There you go. Good suggestion, Google. Now for NVIS, you can see my area and the destination are in that dark blue, which is 8 megahertz. So for NVIS, it's getting close, but this isn't quite NVIS. So very exciting shit. Forgive the S word. There you go. High energy LMD wave system. And if my choke idea isn't optimum, I can simply choose to only have it at that height above ground or place a radial system at that height. 7.3, and thanks for watching. Oh, and whoops, I almost forgot. I should show the actual power setting, because in the past I have had people accuse me of running high power and lying. So that's it live on the SDR in VK5, as you can see. And this is the radio that's transmitting the beacon. So I will just go into the power setting while it's transmitting. And you can see that is set on 10 watt. There we go. Actually, what I will do is I'll take it down to 5 right now and see how that goes. Alright, so I dropped it to 5 now. So here we are now, QRP on the high energy LMD wave system. You can see it has dropped a little. And I'll bring it back up to 10. Let me see. I suspect the increase at 100 would be significantly more than you would anticipate. So 10 watt. There you go. 7.3, and thanks for watching.